Vitamin B12, typically associated with red blood cell production and neurological health, has an underrecognized but potentially profound influence on fertility. In the intricate symphony of reproduction, where hormone regulation, cellular integrity, and genetic fidelity must align precisely, B12 plays a subtle yet foundational role. When this nutrient is deficient, the disruption may not manifest as an obvious illness but as a hidden barrier to conception, implantation, or full-term pregnancy. For couples facing the emotional and financial strain of unexplained infertility, B12 may be one of the most overlooked but modifiable factors in their reproductive landscape. In women, vitamin B12 is crucial for healthy ovulation and the creation of a receptive endometrium. This stems from B12's central role in the methylation cycle, which governs DNA synthesis, gene expression, and the recycling of homocysteine. When B12 is low, the entire methylation process becomes impaired, leading to subtle hormonal imbalances that can interfere with the timing and quality of ovulation. Estrogen and progesterone signaling may become blunted or erratic, reducing the likelihood of a mature egg being released and fertilized. Meanwhile, the uterine lining may not reach the appropriate thickness or cellular readiness to support implantation, even if fertilization occurs. These microscopic derailments may go undetected by conventional fertility workups, which rarely test B12 status unless anemia is present. The methylation issue has even deeper implications. During the early stages of embryogenesis, DNA methylation is essential for proper gene silencing, imprinting, and cellular differentiation. B12 deficiency can increase homocysteine, a known teratogen and inflammatory molecule, which may interfere with embryo quality and increase the risk of miscarriage. In some studies, women with low B12 or elevated homocysteine have been shown to have higher rates of early pregnancy loss or recurrent miscarriage. While folate is more commonly emphasized in prenatal care, it cannot function optimally without B12. The two vitamins are interdependent, and ensuring both are present in sufficient amounts is critical for successful conception and fetal development. Men, too, are affected by B12 status. Sperm production is a highly metabolically demanding process that requires sustained DNA replication and mitochondrial energy output, both of which depend on B12. Low B12 levels have been linked to decreased sperm count, motility, and increased DNA fragmentation in sperm cells. These issues, while often subtle and reversible, can meaningfully reduce the likelihood of fertilization and successful embryo formation. Some research even suggests that B12 supplementation may improve semen quality in subfertile men, particularly when paired with antioxidants or methyl donors. It is likely that B12 supports not only sperm quantity, but also sperm resilience, especially under conditions of oxidative stress. What makes B12 especially intriguing in the context of fertility is how frequently it is insufficient even when blood levels appear normal. This is especially true in populations with marginal absorption capacity: older adults, vegans, vegetarians, people with digestive disorders, and women on long-term oral contraceptives or metformin. In these groups, functional B12 deficiency may quietly affect reproductive health without triggering anemia or other classic warning signs. Many fertility clinics do not routinely test for methylmalonic acid or homocysteine, markers that reveal subclinical B12 dysfunction, so the role of B12 may remain invisible until deeper testing is pursued. Importantly, this is a nutrient with high therapeutic potential and low risk. Correcting B12 status, either through dietary changes, oral supplements, or methylcobalamin injections, can often yield improvements in ovulation patterns, endometrial thickness, sperm morphology, and early embryonic development. For couples pursuing assisted reproductive technologies, ART, B12 optimization may increase the efficiency of procedures like IUI or IVF, supporting better implantation and pregnancy outcomes. And unlike pharmaceutical interventions, B12 carries minimal side effects and is relatively inexpensive, making it an attractive adjunct to conventional fertility care. The story of B12 and fertility ultimately invites a broader reevaluation of how we define deficiency. It asks whether normal lab values are enough in people with elevated physiological demands or subtle metabolic bottlenecks. Fertility, by its nature, is a threshold process. It does not simply require enough nutrients to avoid disease, but an abundance of them to sustain the most delicate and energy-intensive processes the body can perform. In this context, B12 is not merely a supporting actor. It is part of the blueprint for life, influencing cell division, hormone signaling, and gene transmission from the earliest moments. As more research illuminates the intricate biochemistry of conception, it is becoming clear that B12 deserves a place alongside folate, iron, and vitamin D in the foundational discussion of reproductive health. For some couples, optimizing this one nutrient may quietly shift the odds toward conception, making the difference between prolonged uncertainty and the start of a new life. In its subtlety lies its power, and in its restoration, the possibility of renewal.